niambie tumerudi kung'ang'ana na Regex.
Hata jana tangu tuachane sikupata time ya kuzipitia.
But see, you have like already you had like an idea of like Regex.
Yeah.
Okay. Sawa, nini hata mtatufanyia leo basi.
Sawa.
Evans ni aje?
Poa sana, ni aje?
Fiti. Ulipata time ya kuangalia hizo challenge zilikuwa zimebaki?
Si zote lakini tuliangalia 2-3 hivi.
Sawa. Sawa, acha tuendelee. Tumefika wapi? Umefanya dot. I think siko hapa. I think tulikuwa kwa ranges. Wekesa, si tulikuwa hapa, si ndo ulikuwa na solution ya umeandika aje? BBYY. Alafu
umeshare screen? Mimi sioni screen.
share. Ala. Kumbe sija share screen, nimerecord but sija share. Sorry. Imekam.
Imekuja.
Sawa. Haya, so ile solution yako ya jana ulikuwa umeandika aje? Unaweza kumbuka? Haya, so the question was we only want to match Anna, Bob and CPC. We don't want to match AAX, BBY na CC, Z or Z. So tulikuwa tumeangalia character using the ranges easy. So if you have the not, you're not including the patterns hapa ndani within your search. So can you remember the way you had done it?
Yeah. So how I did it, niliangalia kama unaona hiyo skip ya kwanza ni A na X. That's the pattern. Na hiyo pattern haijarudiwa anywhere else. So nikeka hiyo hearts. Alafu nikeka the whole pattern AAX. So it exclude hiyo yote. Yeah, then I went to the other one. Hivyo BBY na exclude the whole word. Same to CC7.
Okay, sawa. But so like isipokuwa like Davis. So Davis, what you are doing is, I think what you can do is, let me see. Hata tuko mbali sana, it's just 5 lessons. So tunaweza anza hapa haraka tukienda, ndio tukifika hapa tutaendelea. So we'll do a recap actually. So basically what regex is, it's a pattern basically. You're trying to look for a particular pattern in a string or in some text. So over the various lessons, you'll be introduced to a number of special meta characters used in regular expressions that can be used to match a specific type of character. So below are a few more lines of text containing digits. Try writing a pattern that matches all the digits in the strings below. And notice how your pattern matches anywhere within the string, not just starting at the first character. So basically, regex was doing some challenges up as a note school. Regex, we'll go through them, get time. So essentially, I don't know whether you guys know of this extension called Markdown Preview. So if you have some Markdown text and you umeandika kwa readme yako, you can preview it like this. So this information, you can just read it hapa, a blog or something. So we looked at the definition of regular expressions. So it's a sequence of characters that forms a pattern. That's basically what it is. If you are going to remember anything, remember that. And then in JavaScript, we have two ways of writing regular expressions. You can either use the regex exp constructor. You can see the new keyword is here. This will create a pattern with M, capital M, small I, K, E, or you can use the literal notation. So you just pass in the pattern, but you use, in this case, you use the slashes. So now this is telling the engine that anything hapa katikati is a regular expression. So those are the two ways of defining regular expressions in JavaScript. Now, when you want to test for a pattern in a string, you can use the test method. The test method and the match method, but we'll look at the test because the test is what you normally see a lot of times. Did I not include it here? Let's see. Looks like nilitoa. So let's look at the JS file. So I will come here and I will print out some of this. Let pattern equal to, and this is a test method, and this is a console log. Then what is going on here? We have another let kuchini. So basically, we are checking whether our pattern mic exists within this string, this sentence. So we use pattern.test, and this will return a Boolean value. So if the pattern exists, so if you have mic hapa ndani, it will return true. If we don't, it will return false. And then we have these things called flags. So the I flag is telling the pattern to be case insensitive. So find mic, whether mic is capital M or a small m or capital I, it doesn't matter as long as the pattern is M-I-K-E, regardless of case. And then global is telling it find all occurrences of mic, not just the first one. Because by default, if you don't have the global flag, it will stop after it finds the first match. But if you want to find multiple occurrences of the pattern, then use the global flag, which will give you mic twice. Ya kwanza na ya pili with a capital M. So that's basically what regex is. That's what they are, and that's what they do. And then we looked at the dot, a wildcard, which is used to match anything. You can use it to match anything. So the way you write it again is you simply replace whatever is here with a dot, a period, what you want to call it. Now this will match anything, any word, any character, any number, any symbol, anything. It will match anything. It's called the wildcard. If you've ever used Linux is very, especially the bash, Bonagen shell natumianga a lot of regex, like grep. If you ever used grep, the grep utility in Linux, it uses a lot of regular expressions. So this simply matches anything. So now if you want to match cat 896 with a period, question mark, basically isipokuwa hii ya mwisho, you'd have to write a regular expression for it. So we want to match cat 896 period, question mark equal sign plus period, but not ABC1. So can someone remind us how we solve this, or can you guys see how we can solve this one? I want to skip the last one. How can we solve this one? We want to not match A, B, C. Because if we write this, if we write a dot, it matches everything. And then when you want to use the actual period, then you can escape it using, so you can do this. So this works. This is what we did yesterday. We are only matching the last dot here, hapa. It's right here. The last one doesn't have it, that's why it's passing. So I think that's it for just a recap. I think we can continue from here now. The last one we checked was character ranges. We have finished that one. Done with that. So now we want to look at catching some Z's. Okay. So we've so far learned how to specify the range of characters we want to match. But how about the number of repetitions of characters that we want to match? One way that we can do this is to explicitly spell out exactly how many characters we want. For example, we can use this format. So basically, this simply looks for any digit from 0 to 9. So this is a shorthand syntax for digits. So you want 3 digits kama zimefuatana. You want a digit here, another digit here, and another one here, 3 of them, which would match exactly 3 digits. A more convenient way to specify how many repetitions of each character we want is using the curly braces notation. For example, A curly braces 3 will match the A character exactly 3 times. Certain regular expression engines will even allow you to specify a range for this repetition, such as A opening curly braces and then 1, 3. This will match A no more than 3 times, but no less than once. You're telling it to match at least 1 or 3 times, 1 to 2 to 3 times, but not more than 3 and not less than 1. So this quantifier can be used with any character or special meta characters. For example, W and then 3 gives you 3 W's. And then when you have the bracket notation and then W, X, and Y, and then 5, this gives you 5 characters, each of which can be a W, X, or Y, and period 2 and 6 gives you between 2 and 6 of any characters, of any character. So now for this one, we want to match this, we want to match this, but we don't want to match this. How can we match these first two using that notation, the curly braces? Anyone have an idea how we can do that? We want to match the first one and the second one, but not the third one. Just look at it. What are the differences between the first two and the last one that we want to skip? Anyone with an idea of how we can do that?
What if we match the letter Z from 2? Like we write Z, curly braces, then 2. I think that will work. Because we're just excluding the 1.
Yes, so that works. So we are only matching, remember the regex engine, the way it's working, it's looking for 2 occurrences of the Z or the Z. And it will only match if we have 2 of them following each other, one after the other. That's why this one doesn't match. Because yes, we found this one, but we didn't find another one. We found 1 and we need 2, at least 2. So this works. Okay, so we can continue. So this is how you like match pattern repetitions. So we can go on.
Question kidogo. What will happen if we did you kwa hiyo equation, equation Useme Z3. Singe bado ingematch ama what will be the problem?
Wapi? Hapa sasa. What if we did what?
Sio ya kwanza tufanya 2. What if now we do 3? Itakuwa the same thing.
It will still work. Because now we've just matched easy tatu. So yes, it will still work. So there's a bunch of ways to like solve these challenges. So as long as it's skipping the last one because the last one has 1, then it works. But you're trying to make the Regex engine do the least amount of work possible. If it can get the correct answer just by doing 2 of them, the better. It doesn't have to do the third one because the thing we are trying to skip is just 1 with the 1Z. So this would work. Even 4 would work, or 4 would not, because this one only has 3. So that's why it's working. So 4 is not working because this second one has only 3.
Okay, understood.
Yeah. Continue. Okay. So a powerful concept in regular expressions is the ability to match an arbitrary number of characters. For example, imagine that you wrote a form that has a donation field that takes a numerical value in dollars. A wealthy user may drop by and want to donate $25,000, while a normal user may want to donate $25. One way to express such a pattern would be to use what is known as the clean star and the clean plus, which essentially represents either 0 or more, or 1 or more of the character that it follows. Okay, for example, to match the donations above, we can use the pattern D and then the asterisk. So you have a slash and then the asterisk to match any number of digits. But a tighter regular expressions would be /D plus, which ensures that the input string has at least 1 digit. So the difference between the two is the asterisk will match 0 or more times. So even if you don't put anything, but it a match. The plus will ensure that it will match at least once. So 1 or more. And the star is 0 or more. Okay, so these quantifiers can be used with any character or special meta characters. For example, A plus is 1 or more A's, and then ABC plus is 1 or more of many A, B, or C character, and period asterisk is 0 or more of any character. So below are a few simple strings that you can match using both the star and plus meta characters. Okay, so we want to match this one. We also want to match this one, and we also want to match this, but we don't want to match this. How would we go about doing that using either the star or the plus? So we want to match the first one, the second one, and the third one. Look at them and look at the difference that they have. So we want to match the first, the second, and the third. Has anyone seen the solution? Let me send this in the chat. Nimetuma hiyo link. So we want to match this, we want to match this, and we want to match this. So the star matches 0 or more, the plus matches 1 or more. So how can we try to start and see what can we write here just to start? See what it matches. Anyone?
Okay, I think since we are skipping only one A, we can start 2 A's.
So that already works. because the thing we are typing C, it's just 1A. So this works. Any other solution? Can we make use of the star anywhere or the plus sign?
I'm thinking about how we can use the plus sign. And since the third one, there isn't a B, maybe if we put them in between square brackets.
So we put
ABC inside square brackets.
ABC.
And then we add a plus to show that at least once or more.
You know why it's not working? Can you see why it's not working?
Okay, let me think that.
Yeah, because it's not working because the last one is matching. Because you've told it A should appear at least once, and A is appearing once. Upper. So it's matching because of the A appearing.
What if we put A outside the square brackets?
Because you're matching either A or B or C one or more times.
What if we put A outside the square brackets?
Yes.
And move it inside?
It still works. So it's already working even now.
Yeah.
Because this
so
first A, yeah,
there has to be an A, one A and then other A's.
Yes, other A's or other B's or other C's. But basically, it has to be followed by something that is occurring one or more times. So what if we put the asterisk here? Will it work? If you put the asterisk instead of the plus sign?
It should work.
It should work. Why do you think it should work?
Because it checks for the presence of that character 0 or more times. So if probably I think that's the case. I don't know exactly.
Okay, good attempt, Evans. Anybody else? If we put the asterisk, will it work?
I don't think it will work. Because it's going to also match the last one, because it's going for 0 or more times. So it's still going to match the last one, which was supposed to skip, because it's going to assume that can't explain it really, but we have one A outside, so that is going to match the last one. And when we use the asterisk, it's going to imply that it can either be, they can either be no 0 A's or more.
So we can either have an A 0 times, so inaweza kosa kuappear at all. So
inaweza kosa kuappear at all. Yeah.
And it will still pass.
It won't.
Why not? If you put the asterisk, because remember this first character hapa, this represents the first character. Yeah. So this is this.
Yeah.
So now with the current implementation tunaiambia, make sure we have at least one occurrence of either A, B, or C after the first A. And the asterisk, what is the asterisk doing? Try to remember what the asterisk is doing. The asterisk is saying 0 or more. It's not working because the asterisk is it's saying basically the second digit can or cannot exist 0 or more times. So even if it doesn't appear, still pass because it's 0 or more. The plus is working because it has to appear at least once. So we need either a letter A here, a letter B, or a letter C. That's why it's not working, because this one just has the one A. But the asterisk is telling it if a letter A or B or C does not appear here, you can still pass because the asterisk is 0 or more. So 0, it can appear 0 times, which it's doing for this last one. It's appearing 0 times. So it is passing. I don't know kama umeshika, but it's confusing.
But we can make the asterisk work in a different way. Just after our first character, can use
so
the plus sign.
Nitoe hii hapa ama asterisk?
Yeah, toa.
Okay.
So after the first character, you can add a plus sign to add a plus sign there, and then remove a from inside, and then use the asterisk outside, so that
I remove what?
The a inside the square brackets.
Remove the a, and then
or just leave it like that.
So why is this one passing?
If you wanted to match the whole strings, like all of the whole strings, because it's just matching a part of the string.
Yes.
You can use the asterisk after the square brackets, so that you can imply maybe if you wanted to really use the asterisk.
Okay, so we put the asterisk here.
Yeah, it's going to match the whole string.
Okay. So it's matching all of them. What about the plus sign? Would the plus sign also work the same way?
The plus sign would work. Yeah. Different. It's just the same thing.
Okay. You see, there's a difference.
It's not passing unless we specify a to be 2 characters. We use the curly braces.
Yes. Okay. I see you got it. No, I was trying to see kama umeshika. Okay, sawa. So let's go to the next one.
A question. Can you go to the previous quiz? Yeah. So the plus after the brackets, is it also affecting the A or only the B and C?
Only the B and C. It's not affecting the A. Because the A is being matched.
But if it's not affecting the A, how comes when we use an asterisk, it doesn't match? And also, if it's not affecting the A, if we only leave A plus, will it work?
Will not work.
So it means the asterisk is affecting everything. Okay, I get it.
The asterisk. So let's do. So when you put the asterisk, what are you doing now? Why this one here? Try to figure out why this one is failing. Because I was actually explaining. Because do you mind explaining why this one is passing? Because this is passing when you put an asterisk.
I'm asking the question. I'm the one asking the question.
Oh, it's you.
Yeah.
So who was answering? Was it Mambo?
Yeah, it's me.
Yeah, Mambo. Can you?
So that fails because we have B and C inside the square brackets, and we are using the asterisk keyword, which implies that either we can have 0 or more B's. So basically, what we're supposed to skip matches because there is a single A which matches our first character, the A plus, and also matches this other part of the square. Because even though we do not have a B or a C, it still matches because it implies that we should have 0 or more characters. That's why the solution does not work.
Yeah. So essentially, So E, this one here, this first one, this here, E, we are matching A's one or more times, right? That's why it's passing here. Baka hapa, because A's have appeared one or more times. And then here, we are passing because hapa, we have A's appearing one or more times. So the B's and the C's inatoka kwa hii ingine, kwa hii bracket hapa. Because we're telling it, asterisk is saying appear 0 or more times. So the multiple B's, the multiple C's that are matching, it's because they are appearing more than 0 times. It's matching everything. So 0 or more. And then this last one is failing because we are saying, right, for the second character hapa tunaiambia, you don't have to get a B or a C. As long as you have an A, at least one A, you can pass. So it's passing because there is one A, so in a pass. But this now, the BC is only working for the asterisk. The asterisk is covering just the things in the brackets and nothing else. You'll get it. We'll do more examples. Like it makes sense to say. Okay, let's look at the optional character. So as you saw in the previous lesson, the clean star and the plus allow us to match repeated characters in a line. Another quantifier that is really common when matching and extracting text is the question mark character, which denotes optionality. This character allows you to match either 0 or 1 of the preceding character or group. For example, the pattern A, B, question mark, C will match either the strings A, B, C or A, C, because the B is considered optional. So this matches 0 or 1s. Similar to the dot meta character, the question mark is a special character and you will have to escape it using a slash to match a plain question mark character in a string. Okay, so in the strings below, notice how the plurality of the word file depends on the number of files found. Try writing a pattern that uses the optionality meta character to match only the lines where one or more files were found. Okay, so what are we looking for? We want to match one file found, question mark. We also want to match 2 files found, question mark. We also want to match 24 files found, question mark, but you don't want to match no files found, period. Let me send this link again to the guys who just joined. Okay, so we want to match this one, we want to match this, we want to match this, but we don't want to match the last one. How do we do that? Has anyone seen how we can do that? Nimetuma link ya this challenge is a chat. You have a look. Anyone figured it out?
I think to begin with, you can use because the ones you want to match have a digit, you can use /d. /D. Yeah.
Good. That's one way of doing it. That already works. How else can we solve it? Anybody? How can we solve it again? What other thing is different between the ones we are matching and the one that we are skipping, other than the digits?
Question mark.
Question mark. So we pass the question mark.
Yeah.
With a backslash so that it can escape it.
Yes, because when you just put the question mark, it's the optionality. When we escape it, now it's actually looking for the question mark. So it's passing also. Okay, I see you guys are getting it. So any questions up to this point? I think they are making sense, pole pole. They're going to get more and more complex. Okay, let's continue. Okay, so when dealing with real world input, such as log files and even user input, it's difficult not to encounter white space. We use it to format pieces of information to make it easier to read and scan visually, and a single space can put a wrench into the simplest regular expression. The most common forms of white space you will use with the regular expressions are the space, the tab, the new line, and the carriage return, useful in Windows environments. And these special characters must each match each of their respective white spaces. In addition, a white space special character \s will match any of the specific white spaces above and is extremely useful when dealing with raw input. So this will match anything, the tab, the new line, anything with a match sort and a return. In the strings below, you'll find that the content of each line is indented by some white space from the index of the line. Try writing a pattern that can match each line containing white space characters between the number and the content. Okay, so let's just look at what we're trying to match. So you want to match 1 period or dot or full stop space ABC. You also want to match 2 period space ABC. You also want to match 3 dot space ABC, but you don't want to match 4 dot ABC. So we don't want to match the one that doesn't have white space. How do we go about doing that? What's the first thing we can do?
Can use \s.
So what are you matching in this case? You're just matching?
Just checking those that have spaces.
Okay.
And
yes.
The last one doesn't have a space.
Doesn't have a space, yes. So it's just matching just one space anywhere in the strings. Just one space. Okay,
yes.
Good. Very. Anybody who has seen another solution?
Yeah.
/d
for the numbers.
And
then #dot for the any.
For the we skip the dot.
Yeah, and then /s.
Yes, that also works. Okay, good. I see you guys are getting it now. Okay, we can continue to the next one. Starting and ending. So far, we've been writing regular expressions that partially match pieces across all the text. Sometimes this isn't desirable. Imagine, for example, we wanted to match the word success in a log file. We certainly don't want that pattern to match a line that says error, unsuccessful operation. That is why it is often best practice to write as specific regular expressions as possible to ensure that we don't get false positives when matching against real-world text. One way to tighten our patterns is to define a pattern that describes both the start and the end of the line using the special heart character and $ meta characters. So this one is matching the start and this one is matching the end. It will only match at the end, the $. In the example above, we can use the heart success to match only a line that begins with the word success, but not the line error, unsuccessful operation. And if you combine both the heart and the $, you create a pattern that matches the whole line completely at the beginning and the end. So note that it is different than the heart used inside the set of brackets. You remember we were using this to negate values. If you don't want something to appear, This is for excluding characters. Okay. So now we want to match mission, full colon, successful, but we don't want to match the other two. Let's try to figure it out. How would we just match the first one? Take some time, look at it. How can we use the $sign or the heart symbol? Has anyone, what can we try first? To just see what it gives us before anything else.
You can try a heart and an M, capital M, because it starts with that.
So, heart symbol, M. Okay, good, that matches. But what if we wanted to match successful? How would we match successful and not unsuccessful? Is there a way we could match successful?
Okay, it is, there are two successes, one in the match, another one in the skip. So
yeah, I can see that.
So maybe include the whole line inside the bracket.
Yeah. So we can't do it. Doesn't look like we can, because we also have a successful in the skip. But what is the difference between those two? Has anyone seen another solution to this?
We can write the whole line, mission successful.
Yeah, we can write the whole thing. But in that case, then we don't even need the heart, do we? There's space or not? Okay. Failing. Yeah. So we have to say start. Okay, so that works also. Put the whole pattern. Okay. So it's not possible to just match successful because of it's also here. And I don't see a way to not match it. Okay, I think we can move on. Okay, let's go to the next one. Okay, matching groups. So regular expressions allow us to match, to not just match text, but also to extract information for further processing. This is done by defining groups of characters and capturing them using special parentheses, meta characters. Any sub-pattern inside a pair of parentheses will be captured as a group. In practice, this can be used to extract information like phone numbers or emails from all sorts of data. Imagine, for example, that you had a command line tool to list all the image files you have in the cloud. You could then use a pattern such as whatever is there to capture and extract the full file name. But if you only wanted to capture the file name without the extension, you could use the pattern that they've highlighted there, which only captures the part before the period. So let's dissect this one. So this would give us a group. that has the image plus whether the image has a number, digits, 0 or more times, and then the extension. But so this would give us that group, but this one would exclude the extension. So the .png, .jpg. So this is how you do capture groups. So now the question here now is, we want to capture this one, and we want to capture file record transcript, but you don't want to capture PDF. We also want to match file underscore that number, but we also want to we only want to capture this section here, not the PDF. But you don't want to capture this one at all. How do we go about that? Has anyone seen? So we want to use capture groups. So let's just put them in there first of all and see. So if I put an F, we are matching, but I want to match F up to pale kwa dot and just capture that. So to maybe illustrate better. So that's what we want to match. But because we also want to match this, and we can't keep writing, we can't write both of them. So how would we write this in a different way based off of what we've already done? What meta characters can we use?
You can start off with the heart so that to show it's the beginning.
So we start with the heart.
Yeah.
Okay.
Inside the parentheses, you can write file. Followed by the stroke W to show letters. Plus you with a plus so that it shows it's one or more. Yeah. Then that works.
Yeah, that works.
We can finish it off maybe specifying it's a PDF.
So outside
you can use the backlash, then full stop, PDF, then the $sign to show the end.
Works. Good.
But Apo, are you supposed to capture the extension?
No, you are not. Because you see, the capture group is whatever is in the parentheses. So that's why it's matching, because it's just capturing the file record. So even without this, it still works. But then again, you should always try to make your regular expressions as not so expensive. You don't want the Regex engine to have to go an extra mile. So as much as this works, you actually did not need this section here. You want it to exit the minute it captures this thing. You no longer need anything else. But that was how you would implement, like if you want to find the whole thing, you do that as well. Anyone else with another solution they've seen? Okay, I think we can move on. Let's continue. So nested groups. Okay, so I think this is almost the same thing, but now we want to have a group nested in another group. So this example they're giving us here is if you wanted to capture two groups, so one for the image, right? One for the image right here, and one for the digits right here. That's essentially what you're doing. We're creating two groups nested within each other. So we have the parent group, and then we have the nested group. So now for the question is basically asking, how can we match this, all of it, and also match this? How do we capture both of them? So again, we will, starting point is this. Okay, who wants to take us through that thought process? How would we capture those two groups? So let's start with just the first capture group, Jan 1987. How would we capture Jan 1987? Anyone? How would we capture 1987? So I'll do a both one. Maybe this will give you guys an idea. Passing Jan 1987, capturing the first one. If I do 1969, May captures the second one. If I do 1969, captures the second capture group. If I do 87, it captures the first capture, but the second capture group, because the first capture group is Jan 1987, and then the second one is just the year. So how would we capture both using one pattern? Anyone? Has anyone seen the solution? What if we used the meta characters? So okay, so that gives us the first letters. What if we said, okay, so that gives us mpaka hapo. So how do we capture that group only? What do we do next? We already have the first. So we want all of it. We want the first capture group to be all the way back in 1987. How would we capture that first one? Just E kwanza to E moja E. How would we capture that? What if we put this? And then we put digit. Capture the first one. So how do we capture the second group? This one.
We can nest the digits after the white space. Yeah.
Yes. Is it making sense why it's working? Let's do it again. Let's go through it again. So we want to match this whole thing. And this whole thing, the pattern is we want alphanumeric characters 0 or more times, but that does not include that meta character does not include white spaces. So for you to include a white space, you give it the S. So that is now also including the white space. Then if you want to also include the digits, then you have the digits, but you don't want one digit. You want one or more digits. And then if you want to capture a group within that group, you simply wrap that group. I do. Am I missing a capture group somewhere? I was missing a parenthesis. So this is matching these digits. It's matching any digit one or more times. So it needs to happen at least once. Okay. Any question or an alternative? Any question? They're getting more involving. Okay, we can go to the next one. Okay, more group work. Okay, as you saw in the previous lessons, all the quantifiers, including the star, the plus, repetition, which is calibraces M, and then N, and the question mark can all be used within the capture group patterns. This is the only way to apply quantifiers on sequences of characters instead of the individual characters themselves. For example, if I knew that a phone number may or may not contain an area code, the right pattern would be, the right pattern would test for the existence of the whole group of digits. So you have your parentheses, your /D 3 times, and then you have your quantifier, the question mark, outside of your parentheses. So it will check for the existence of 3 digits, 0 or ones. So if it's there, it has to be 3 digits and not the individual characters themselves, which would be wrong. Depending on the regular expression engine you are using, you can also use non-capturing groups, which will allow you to match the group, but not have it show up in the results. So you'll match the group, but it will not show up in your results. So the question is, we want to capture 1280 by 720. We also want to capture 1920 by 1600. We also want to capture 1024 by 768. We want to capture all of them. What pattern would we use to match them? Based off of like using groups. Again, look at it, take your time, see whether you can figure it out. So again, let's do like hard coding. I put 1280. We are matching the first capture group. How do we do that without writing it out that way, like using capture groups or using like quantifiers, calibraces? How can we do that? Or just a simple solution? Optimize it. What is the difference between the first two and the one at the middle? How do you capture those groups? Because we want the first capture group to capture 1280, and then the second 720. The second one should capture 1920 and 1600, but they should not capture the X. Has anyone seen the solution? What can we try? What have you guys tried so far? What if we try to match the first group to just be digits, and then we tell it we want 4 digits for the first capture group? Would that work?
I've found a way of matching like the first number separately and the last one separately. So maybe you can start there. So to match the first one, you start with those groups, and then you put the starts with I think the starts with thing that the up facing like angle thing.
The hat.
Up. It's the up facing angle thing. You're calling it the hat, or?
Which one? Hii kofia hii.
Angle inaangalia juu, hiyo. Like iko nje, hiyo kofia iko nje. Anza na hiyo. Then inside the group /D plus it match the first group, because like and then if you want to match the end group itakuwa instead of hiyo hat huko mwisho iko $ ends with, but mixing them together and the kizungumkuti.
So we also give it /D
plus then the dollar thing.
Like you have to remove this now.
No, we
match.
You need to put the X.
Okay.
To capture groups.
So we need to put the X. What we have.
Yeah.
Yes. Because we do want to match, but the grouping is what we are thinking.
Text too.
Yeah. Can we make this? What can we remove to still make it work? What can we remove? Can we remove the $sign?
Instead of X, can we use /W?
Yeah, or kwa zote mbili, and still use W. No, but W might match the X. I think the W will match the X also, because W is alphanumeric. So the W will match the X as a group. It should match it as a group. So let's try. Oh, it's still working. How come?
When you get rid of that X, it will still work again, I think. Yeah.
Not working.
But now the groups are not.
But let's go to, I'm still going to. So this is alphanumeric.
Alphanumeric is both numbers and letters, so maybe it's matching for the first group, whether they're numbers or letters.
But that would mean it would also put the X as a group. Maybe
the grouping looks like it's from maybe the start and then separated by an X.
I think the X is what is now making it not match. Because alphanumeric, the W will also match the letters.
Alphanumeric. I thought alphanumeric is only in letters and numbers. I'm not sure.
It is, but this is also a letter. This is a letter, so this should also match X. Because
it's not like times, the times, maybe it's the times, you know.
Yeah, because if we remove this, unaona, it's matching the X.
Oh, so it's like X, not a times. I thought it was a times.
No. It's an X. So it's matching this as also because it's an alphanumeric value.
Oh, okay. I thought different.
That's weird. It is matching. You can see it here. Okay, interesting. Can we remove anything and still make it?
What if you remove from X going forward? Remove everything.
I remove what? I can't hear you well. I remove
X and plus B, everything in brackets.
Plus B, then
the whole bracket thing. Remove everything inside.
Remove everything in the brackets.
Yeah.
Both brackets. Oh, I remove everything completely.
The second group. No, remove the second group. Then inside, after the plus, now we exclude the X. We what?
I do what?
We exclude the X with the square brackets. Then hat X. Oh, it's not working.
It's not working. Let's go back to that solution again. Let's walk through it again. What are we trying to do? We are trying to capture the first group to be digits, or as you've seen alphanumeric, because right now it's also matching, it's just matching one. We want multiple occurrences of digits. And then we want a character here, any character. 30. So can we use the period symbol here? Can we do period and then because that's working, because this can be anything. Just like we were doing the X. That still works also. So we don't even need the heart symbol, because all of them they look the same. The beginning is the same for all of them. Hakuna yenye imeanza na a letter. They all start with numbers. Okay, let's do the last one. I think imebaki moja. Okay, this might be the last one. Let me see. The last one. Okay. I don't even think we need to. So here you can use they're talking about the logical or the pipe symbol. You've seen it in like most programming languages. So basically, what they're saying is, as we mentioned before, it's always good to be precise, and that applies to coding, talking, and even regular expressions. So for example, you wouldn't write a grocery list for someone to buy more, alafu weke the period and an asterisk, because you would have no idea what you could get back. Instead, you could write buy more milk or buy more bread. In regular expressions, we can actually define these conditionals explicitly. Specifically, when using groups, you can use the logical or, aka the pipe, to denote different possible sets of characters. In the above example, I can write the pattern buy more milk, buy more, and then parentheses, milk or bread or juice to match only the strings buy more milk, buy more bread, or buy more juice. So like normal groups, You can use any sequence of characters or meta characters in a condition. For example, parentheses, square brackets, CB, and then ATS. That pattern would match either cats or bats or dogs or hogs. Writing patterns with many conditions can be hard to read, so you should consider making them separate patterns if they get too complex. So go ahead and try writing a conditional pattern that matches only the lines with small fuzzy creatures below. So you want to match I love cats, I love dogs, but not I love logs and I love cogs. How would we do that? How would we match I love cats and I love dogs, but not the last two? Has anyone seen how we can solve that? What is the difference between the first two and the last two? What characters are different? So what if we wanted to, okay, let's just try the way we've always been doing it. What if we, so if we wanted to match cats, we'd write cats. So what if we also want to match dogs? What would you write? Can we use the pipe here?
Pipe dogs. Maybe we can check. I think you can check ends with cats or dogs.
Okay. So we
do the group. Yeah, dogs. Yeah. Estimates.
Yeah. Is there any other solution for this? Yes, there is. We can make it less. What else can we use to check? What if we...
You can check for A and B.
A and D. A and D. A and D. Okay, yes. Because you're checking this and this, indeed. Okay. Good. Any other that we can do? Also CA. CA and D. CA for this one. That will exclude cogs. You can also check for... I don't think there's another one. Has anyone seen another one? No, I have not seen another pattern. I think kuna ingine.
TND.
TND. TND also works. Yeah, TND will also work. Yeah, because you're checking this D and this D. Good. See, it's starting to like make sense. Okay, so this is the last. I think this is the last challenge, the last lesson. So basically, this whatever they've written here is just like a recap, pamoja na some other newer symbols. So when you don't want white space, you put a /S. When you don't want alphanumeric, put /W. When you don't want digits, you just change them out with their capital letter counterparts, and it will work. This one for the border, So there's a special meta character. I think I'll let you guys read on this one. I wanted us to go through some node school challenges because they also have like very examples. But let's try to figure this one out even without reading, because this is the last lesson. So match other special characters. So we need to match the quick brown fox jumps over the lazy dog. Basically, zote. We want to match all of them. Possible ways of doing this based on what we've learned. All the meta characters that we've done up to this point. Meta characters, anything. You can use anything to try and match all of them. I think basically this one will match anything. Let me see. Because they're not giving us anything to actually look for. A T will match, a H will match, a dot will match, that will match, because they're just trying to see whether tumeshika. So if you want to match this whole word, okay, so it's not matching all of it, it's just matching pakapakwa space. Because obviously the white space is not an alphanumeric. If I wanted to match the whole thing using the dot symbol, if I put a plus here, to match the whole word, because we're matching anything one or more times. So anything, including spaces, numbers, anything. Tamatch kila kitu. This one was pretty straightforward. Just like they were just trying to see whether you have understood kila kitu. That's it. So apart from this, there's also another website called Regex. Is it called Regex 101? Regex 101, let's see. One. Yeah, this one is also very nice. So you have your regular expressions here, and then so you have even some reference here. So you have anchors. Anchors is in terms of where the start of the string, which we just looked at, the heart symbol, the dollar sign, and so forth. And so this one is also very nice, this website. You can have a look at it. Now, if you go to VS Code, VS Code also has support for regex. If you press Control F or Command F if you're on a Mac, this option here is regular expressions. So if you hover here, you'll see use regular expressions. Now, VS Code looks like it's also using some form of regex, because when you're writing your code, if you double click on something and you select two things, right? If I double click here and I want to also select this and I press Control D, now I have two cursors here. I can delete both of them. It does look like it's using the first thing that you clicked on, and then it matches the next thing once, just once. Because if I had another body, pattern. So now if you come and double click this, I press Control D again. You can see I have two cursors and I can remove those two. But what if I wanted to also get here tatu hapa chini? Because vile mimi naifikiria, it looks like the first time it's not looking globally. It's not looking for the meta pattern globally. It's just looking for the first occurrence. Alafu inawacha kutafuta. That's why if you press Control D, it just returns the next one that it finds, even though we have another one here. So what if you wanted to find all of them? Does anyone know that shortcut for finding more than 2 of the S code? Because there is a way to do it.
Control-Shift-L.
Control-Shift-L. Control-Shift-L. You can see now it's finding 3 occurrences. If I had more, it would find them as well. So if I come and I add more here, I add multiple letters here hapa chini. I try to just find the first, finds the next occurrence. Moja tu. So this is default behavior when you don't have the global flag. Now, when you now have the global flag set, it will look for all occurrences. So now same select zote and you can delete them at once. So a clear example of something that I think is using regex. I'm not sure, but I have a feeling that's what it's using because it's working with text. Anyone with a question? I wanted us to look at some examples for Node School because they really explain them well, but I think we'll try to do them next week. I hope they're making sense, like regex. They're not so confusing. And by your website, they still have more challenges. You can like go on. They even have one for emails, validating emails. Problem 2, problem 3, I think was the one for, yes, this one. Someone was asking about emails yesterday. You can try this one. Okay. All right, so I guess you guys will, so let's end there for today. And then on Monday, we'll finish up whatever is left before we get into a different topic. But we'll go through those examples are not school because they're very nice also. So, anyone with a question or a comment? I hope you're getting it. Mjapotea sana. George, karibu. I see you joined. How did you like the session?
Imekuwa poa.
Okay. Karibu. Yeah. You're welcome. I see Catherine is also here. Davis, I hope ukupotea sana.
All good, all good.
You okay?
Yes.
Sawa basi. Okay, so I will bid you guys farewell. Tuonane on Monday. You guys enjoy your weekend. Watu wa Chelsea, muendelee kung'ang'ana. Watu wa football pia. Wekesa siwe ni wa Chelsea.
Portable leo kwanza.
Wamenunua maplayer.
Tunatoka soko.
Enzo anacheza leo.
Lazima aanze, hakuna mimi.
Mtatandikwa na Fulham.
Hivi.